Well, hello, amazing physics students. So I went long and I got cut off, but this last slide is really important. So we're going to have a very short video just on this last slide that brings home some key points. So how does kinetic energy change? So if we have a box, my cell phone, going to the right, so that's indicated by our delta x right here, that is the velocity is to the right, and it's being forced to the right. So the net force is to the right, which means the acceleration is to the right. So if the net force and if the acceleration and velocity are in the same direction, the object is, yay, speeding up. Good. So the kinetic energy would increase. So if the kinetic energy increases, the kinetic energy bucket will be filled with more energy juice, or the change in kinetic energy is positive. Okay, so now we have this box and it's still going to the right, but now we have a force going to the left. So if this is also the way of the net force, which is the total outside force, which is what we want to consider right now, the acceleration is in the same direction as our net force, and the velocity is in the same direction as the direction of motion. So if velocity and acceleration are in opposite directions, the object must be slowing down. So if the object's slowing down, the kinetic energy will decrease because the velocity is getting smaller. And so the change in kinetic energy will be negative. Now the last thing that got cut off was this last scenario. So we have this box, my cell phone, going to the right again. But now we have a force that's perpendicular. So as this moves, this force is going to push it. And if you notice, and we will talk about circular motion in a later unit, so this is a little bit getting in ahead of ourselves, but we need to know this for Werk. So as we go, the force doesn't change the speed, it just changes the direction. There's no part of this force that's going to speed up the box or slow down the box. It's all perpendicular to the box. Ooh, I didn't know that I would do that. All right. Okay, so if the force is perpendicular to the box, or any perpendicular component of the force to the velocity or the motion, always just changes direction. It just changes the direction. The speed is constant. That's important. The speed is constant. So if the speed doesn't change, so it's 1/2 mv squared for kinetic energy. The kinetic energy doesn't change. So if the kinetic energy doesn't change, the kinetic energy stays level. And so there is no Werk done. So since Werk is equal to change in kinetic energy. Actually, more appropriately, Werk is equal to change in total energy. We'll see how there are a few examples that, depending on your system, that Werk is equal to change in kinetic plus change in potential. And we'll get to that later on in more robust examples. But this will get you 95% of the way. You're pretty good with that. Okay, on to the next video.